Hey there, I'm Ryan. Welcome back to Things My Students Learned Today. As you may know, my name is Ryan. I'm a science teacher, and I happen to teach 9th grade biology. It's been a while since I have actually uploaded a video, so I wanted to update you guys on what we've been up to in class. It's been a lot of fun, actually. So when I'm teaching science, I'm always trying to double dip, or to use a politically incorrect term, kill two birds with one stone. If I'm going to teach a skill, I try to teach it within the context of what we're learning about. And conversely, if I'm teaching some content, I want to build some skill development in there as well so that kids understand how real life works. We learn the things that are useful to us. We learn better when we put the things we learn into context, and we get better at doing something through repeating a particular skill and then becoming, how do I say this? Get better at it by trying to accomplish more and more complex tasks. To that end, I've got a bunch of 9th graders. I know they're pretty well trained as 8th graders because they came from a feeder middle school, and I know the teacher well, and she has trained them well. But I want to make sure that we're all on the same page when it comes time to accessing data, getting our heads around data, and then probably more importantly, visualizing that data, and then finally writing about that data. To that end, I wanted my students to have a good feel for why there's life on Earth, but we don't find life currently on Mars or Venus, our twin sister, and definitely not on Mercury. And so to set that up, I basically gave my kids access to a bunch of data from NASA that dealt with what I call bulk characteristics: size of the planet, mass of the planet, density of the planet, distance from the sun. We also looked at what I'm calling energy budget, where we looked at each planet's relationship with the sun, not only in terms of distance, but also how much solar energy it receives per square meter. We looked at the angle of that planet and its orbit, because essentially, if it's a flat-on direct hit like Mercury and Venus, even though Venus is upside down, that solar energy is more intense. Whereas with planets like Earth and Mars, they have like a 25-degree tilt. That means that the angle of the sun is slightly more oblique and not as intense, particularly as that planet tilts away from the sun. And then what else we looked at mean temperature. We found out that Mercury's hot, Venus is really hot, Mars is freezing cold, and Earth is somewhere in the middle, has a really nice moderate temperature. So what I'm trying to get my kids to recognize is that this is sort of Goldilocks principle out there. The Earth is a medium-sized planet in terms of the terrestrial planets. It's actually the largest of the four. It gets a lot of solar energy, but not too much, and it's got a nice moderate temperature. Then we move on to the atmospheric conditions, and this is what we've been doing this week. So my students have been looking at, they looked at the amounts of carbon dioxide, oxygen, nitrogen in all four of these planets' atmospheres, and then they looked at some trace gases as well. What I wanted them to do was learn how to work with, well, they also looked at the height of the atmosphere, the density of the atmosphere, and the atmospheric pressure. What I was working on with them today is trying to put two pieces of data in the same graph. And so I essentially tricked them into a little I tricked them into building a column graph by hand by calling it an art project. So the first struggle was figuring out how to set the scale, because Venus has a relatively tall atmosphere, Earth is relatively short, and Mars is somewhere in the middle. We came up with this idea of like, okay, if we go with 18 kilometers, we can make every 2 squares can be 1.5 kilometers. Helping kids figure out how to set appropriate scale is important so they can show off their numbers, but not spend all day drawing and coloring in. Then the fun began. They had all the raw data in terms of the atmospheric concentrations, the concentrations of a particular gas and the atmosphere. I showed them how to set up a table in Google where they could calculate the relative height of each gas. So we did that at the beginning of class, and then we could figure out that, hey, on Venus, atmosphere is around 15.5 kilometers tall, and the CO2 is about 95%. We can show that as an individual column, no oxygen, and then there's a little bit of nitrogen up in Venus. When we look at Mars, it's essentially the same proportions. I had never seen that today. Mars has a shorter atmosphere than Venus, around 11 kilometers. It's, again, mostly 95, it's about 95% carbon dioxide, very little oxygen, a teeny smidge of oxygen, and the rest, the other 5%, is nitrogen. Now you'll notice we got deep red here and light red there. Next week I'll teach my kids about logarithmic scale so we can graph those atmospheric densities. But what I'm trying to visually represent is that even though these two planets have roughly the same atmosphere, same proportions anyway, there's a heck of a lot less matter, a lot less gas on Mars compared to Venus. I mean, think about it this way. The atmospheric pressure on Venus is like 13 bars, and on Mars it's something like 0.06 bars. There's almost nothing there. But I digress, as I often do. What about Earth? If we apply that same idea to Earth, we get a really interesting phenomenon. Earth has the smallest atmosphere. It's bigger than Mars, hugs those molecules close. There's virtually no CO2, 0.004%, 20.9% oxygen, and then about 78% nitrogen. Again, the same three constituent parts, but here we have very little CO2 and a good bit of oxygen, and then nitrogen is left over. Interesting. What I'm trying to seed my kids with is like, okay, why? Why would Earth have more oxygen and less CO2 than these other two planets? They might have an inkling of an idea, but they're not totally sure. Also, an interesting thing I learned today is that kids had never thought about the fact that these atmospheres might change. That's what's cool. I'm planting a seed to get them to think about why Earth is different than its nearest neighbors. Why does life happen here instead of on other planets? And then more importantly, how is it that the life on Earth has actually changed the atmosphere to benefit some organisms while poison others? Super cool. Again, we're just getting started, but giving my kids this opportunity to think about Earth in the context of its nearest neighbors and gets them to think about why Earth is different should give them some context for understanding how biology works on our planet. Probably not the cleanest YouTube video of all time, but it's Friday and I got to meet some friends for beers. My name is Ryan. These are things my students learned today.